So today we're diving into something that is, well, almost beyond comprehension, the science of a nuclear bomb. We're going to break down how it's even possible to unleash the power of a star right here on our own planet.
And just to kick things off, let's start with a fact that is, honestly, kind of mind-bending. For just a split second, the very heart of a nuclear explosion gets hotter than the center of our sun. It's like creating a tiny temporary star on Earth. And that, of course, just begs the question, right? How on earth is that possible? How can we create that kind of cosmic, stellar energy? Well, the answer is probably not what you're thinking.
To find that answer, we don't think bigger, we have to think smaller, like impossibly small. It all starts with a tiny little secret hidden inside the atom. You see, all of this world-changing power doesn't come from some massive chemical reaction. Nope, it comes from the very core of matter itself, the nucleus of an atom, a space so tiny it's almost impossible to even imagine.
Now, it can't just be any old atom. You need a very specific kind, one that has a really heavy, crowded, and most importantly, unstable nucleus. The best way to think about it is like a spring that's been wound up as tight as it can possibly go. It's just sitting there, buzzing with this incredible stored energy, waiting for something to release it.
Okay, so you have all this energy coiled up in countless tiny springs. How do you get it all out at once? Well, you don't just uncoil them one by one. You set off a cascade, an atomic domino effect. This whole process has a name, nuclear fission, and really all fission means is splitting that unstable nucleus. When it breaks apart, two really important things happen. First, it releases all that energy from the spring, and second, it shoots out these little particles called neutrons. And trust me, those neutrons are the absolute key to everything.
Because let's be real, splitting just one single atom, you wouldn't even feel it. It's nothing. The real secret, the part that makes it so powerful, is creating a reaction that just keeps going and going all by itself, growing at an unbelievable speed. That's the chain reaction. And this is exactly how it works. It's like the ultimate set of dominoes. First, one little neutron hits a nucleus. That nucleus splits, releasing energy and a couple of new neutrons. Then those new neutrons fly out and hit other nuclei. Each of those splits releases more neutrons, and the process just explodes. 1 becomes 3, 3 become 9, 9 become 27, and it all happens in a fraction of a second.
So that chain reaction principle is the engine behind all nuclear weapons. But it turns out there are actually two different paths you can take to get there: fission and fusion.
So on one hand, you have the atomic bomb. This is the one we've been talking about. It works by fission, splitting heavy stuff like uranium. But then you have its much, much bigger cousin, the hydrogen bomb. This one works on fusion, which is the same thing that powers the sun. It smashes light elements like hydrogen together. But here's the truly wild part. To get it hot enough for fusion to even start, a hydrogen bomb uses a smaller fission bomb as its trigger. So you literally set off one nuclear bomb just to light the fuse on an even bigger one.
This incredible science, of course, didn't stay on the blackboard for long. It was secretly brought to life during a time of war, and when it emerged, it cast a shadow over the entire planet that's never really gone away.
The abstract theory became a horrifying reality in August of 1945. On August 6th, the first bomb was used on the city of Hiroshima. Just 3 days later, a second one was used on Nagasaki. And 6 days after that, Japan surrendered, and World War II was finally over.
J. Robert Oppenheimer, the man who led the scientific effort, probably captured the feeling of that moment better than anyone. Looking back on the first successful test, he recalled, "We knew the world would not be the same. A few people laughed, a few people cried, most people were silent."
And that silence he talked about, it kind of echoes right through to today. Because figuring out the atom wasn't just about ending a war. It was the start of a whole new era. An era defined by a power we now hold in our own hands.
When you get right down to it, the elegant, beautiful physics of the atom, fission, fusion, chain reactions, gave us something that completely changed warfare, redrew the world map, and really forced all of us to look in the mirror and face what we're capable of. We started this whole thing by asking, how is this kind of power even possible? And we found the answer, hidden in the nucleus of an atom. But, solving that mystery, it just leaves us with a much bigger, much harder question. Now that we know how to do it, can we actually be trusted with it? That's the one science can't answer. That one's on us.